So once again in class, this was our task. Feel free to pause the video and read if you would like to. Okay, and the next page has the resource sheet. So we formed some constraints in the class. I'm just doing a little recap. Over here, this is the setup. So always set up your constraints, okay, and define your variables. Very important. So what I mean by defining your variables is if you're going to use x and y, the examiners don't know what they stand for. It is your variable. So you say let x is equal to. So in this case, we've gone with pardon me, x is equal to the number of hectares of tomatoes, and let y is equal to the number of hectares of artichokes. Now we formed our constraints in class. The first constraint we formed was for labor hours available. Now be very, very careful, please. If it says something like this, artichokes require 20 hours of labor and tomatoes require 10 hours per hectare, rather 20 hours of labor per hectare. That's how the hours, that's how labor is measured in this context. Ted has 1200 hours of labor available. The word available is a constraint. It's setting a boundary. In this case, it's a maximum thingy, okay? What I mean by that is it's the maximum amount. It's a cap. So we can't go overboard. That's all Ted is available. Now, when something is available at its max point, we call it a less than equal to inequality, okay? Second thing is Ted has 90 hectares available. Now, of course, he's doing plantations or planting of tomatoes and artichokes. The exam or the script here is giving T and A, but we've already defined X and Y, so we went with X and Y. This was a free constraint for us. Awesome, thanks for that. Third one, to keep his contract, Ted must plant at least 30 hectares. So here we go, and at least, so that means minimum. The word minimum means greater than equal to. So that's the constraint rather, for planting tomatoes to maintain his contract and so forth for the artichokes. Once you've done all this, you need to put your 4 constraints into a graphing application. I've showed you Desmos in the classroom. Now for graphing purposes and only for graphing, you need to change the signs of the inequalities. Now watch what happens if I just went ahead with exactly what I had as my constraints, okay? You will see the reason we changed that. You see it? There's no white space. Now what I mean by white space in this case is a region to look at. This is like overlap of coloring and you don't quite know. It's not really easy to see ways of region of feasibility. F-E-A-S, feasibility. Google that word if you don't understand, okay? I did tell you what that means, feasibility. And I'm just going to go back to what I had previously. And there we go. So that there is a region. That means the region of feasibility in this context means this. Any solution in this space here will all be satisfying all my conditions. For example, if I chose 35 hectares of tomatoes and 30, so that point there, 30 hectares of artichokes, that will satisfy all the constraints, okay? But we're looking for something which will maximize, hence linear programming. That's the whole assessment really. That's what we're learning and why we're learning, okay? For maximization, for optimization. And that's as far as we got. We created an optimization equation using Ted's income predictions, and that was the recap of the first lesson on this, okay?